guys, this is Unit 11, more specifically 11.1, Exploring Solids. We're going to talk about polyhedrons. A polyhedron is a solid that is bounded by polygons. Those are called faces. It says the plural of polyhedron or a polyhedron are called polyhedra or polyhedrons. So we have kind of three main parts here. We're going to talk about the face. That's like one side, you might say. The vertex down here, that's going to be like one of the points that they all come together. And then an edge is going to be a line segment formed by the intersection of two faces. Right, here are some examples. You can see these are all polygons. Some non-examples, you might want to think things that are curved. Right? Those are not going to be examples of polyhedron. We have two types. First type is a prism that has two bases, which are congruent polygons. And then a pyramid is the other type that has one base, and that's also a polygon. Usually the pyramids go up to a point on the opposite side of the base. It says to name a prism or a pyramid, we're going to use the shape of the base. So in this first example, that has 5 sides, which is called a pentagon. So this is a pentagonal prism because both of the bases are pentagons. In this next one, the base is a triangle. So this is going to be a triangular pyramid. Again, only one base, so it's a pyramid. Before I move on, one note about this, if I go back to that, the bases, scroll down, the bases do not necessarily have to be kind of oriented towards the top or bottom. This could be tilted like on its side, maybe, maybe on like this side here. If that was on the bottom, this and this would still be considered the bases. All right, we're going to label this yes or no, and then if it is yes, a polyhedra, we're going to say which. This first one is yes, those are all polygons, and this is going to be, let's see, there's 5 sides on the base, so that is a pentagonal pyramid. This next one is no, that's a circle on the bottom, so that's not a polyhedron. Next one is yes. This is a pentagonal, again, 5 sides for the bases, pentagonal prism this time, since there's 2 bases. Scrolling down, this next one is not because it has curved sides. Next one is yes, this is a cube. The cube is a square on all 6 sides. It's like a dice. Next one is no, this is like a sphere or a ball. So that's not a polyhedron. Okay, this guy's name is Euler. It looks like Euler. It's actually pronounced Euler. He has a theorem that says the number of faces plus the number of vertices equals the number of edges plus 2. All right, number of faces plus the number of vertices equals number of edges plus 2. Let's see if it works. Number 1 says count the number of faces, vertices, and edges of the polyhedra, then verify Euler's theorem. So on this cube, think of it like a dice. We know there's going to be 6 faces plus the number of vertices. We have, let's circle them here, 1, 2, 3, 4, 5, 6, 7, 8. And that should equal the number of edges plus 2. Let's see if it does. So for the edges, I'll use red maybe. We have 1, 2, 3, 4 going that way. 5, 6, 7, 8. And then up and down, 9, 10, 11, 12. So I fill that in with the 12. Does this work out? This is 14. 12 plus 2 is also 14. Yes, it does. Number 2, count the number of faces, vertices, and edges, and then verify Euler's theorem again. This one, the number of faces, is a little bit trickier to see. I'm going to do this top part. We have 1, 2, 3, 4 faces. Then on the bottom, 5, 6, 7, 8. And then the the base on the bottom would be 9. So it'd be 9 faces plus the number of vertices. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 vertices, and that should equal the number of edges plus 2. Again in red, let's see if we can figure those out. 1, 2, 3, 4 going that way. 5, 6, 7, 8, 9, 10, 11, 12, and then the slanted ones, 13, 14, 15, 16, and we get 18 equals 18, which is true. Okay, the last one, it says a solid has 10 faces and 36 edges. How many vertices will a solid have? So let's remember our formula from before, which is faces plus vertices equals the number of edges plus 2. All right, so let's see if we can fill in what we know. 10 faces. 10 plus, we don't know the number of vertices. I'll keep that as a variable, v. 36 edges plus 2. So we're going to have 10 plus v equals 38. 10 plus what is 38? If I subtract 10 from both sides, the number of vertices would be 28. So this would have 28 vertices. Okay. Regular polyhedron. A regular polyhedron means that all the faces are the same or they're congruent. All right, congruent polygons. So for example, dice. The reason dice work is because every side has an equal opportunity. They're all the same congruent shape. Okay. A semi-regular polyhedron, all the faces are regular polygons, but they do not have to be the same shape. So for example, a soccer ball is made up of 12 pentagons and 20 hexagons. If you notice, the black shapes are the pentagons, and the white shapes have 6 sides, so those are the hexagons. All right, here's some common ones. Tetrahedron, 4 faces, all equilateral triangles. So they do make like 4-sided die. However, it's not the side that lands up, because it's a point that lands on top, so it's actually the side on the bottom that they count when you roll a 4-sided die, in case you're interested. A cube, this is the most common kind of dice, or 6-sided dice. They're squares, all the same. An octahedron is 8 faces. These are all equilateral triangles. This one is kind of like that first one with another one put on the bottom. It's sort of like that, and instead of 3 sides, there'd be 4. A dodecahedron, this is 12 faces. So think dodeca. Do means 2, deca means 10, 10 plus 2. These are all going to be pentagons. And then the largest polyhedron that is regular is called an icosahedron. Icosahedrons have 20 faces. They're all equilateral triangles. I think the game Categories uses this for their letters. There's 20 letters on that in that game. If you ever played that, you roll big old dice. Okay, there's also cross-sections. Cross-sections, cross-sections is the intersection of a plane and a solid. So it's like we're taking that figure, whether it's a dice or a cone or something, and we're cutting it in some shape so that it makes, or some way so it makes a shape. So for example, this says describe the shapes formed by the intersection of the plane and the cube. So these are all cubes here, and that plane is cutting them. So if it cuts it straight through, that's going to be just a square. So what we're trying to describe is like this shape right here. That'd be a square. If it cuts it the long way, that's going to be a rectangle. Okay, this is definitely longer than that, and we know that. We could use the Pythagorean theorem and figure that out if you wanted to. Okay, if it would to cut it this way, here the bottom is going to be shorter than the top. The sides, see, I don't quite know if those are the same or not. Looks to me like that's a little bit longer than this part. So, oops, instead of calling it like a, I don't know, instead of calling it a isosceles trapezoid, I'm just going to call it a regular trapezoid. Okay, because we don't quite know the dimensions. It is possible that it could be isosceles. We'll stay safe and say it's regular. Here it says a 2D representation of a 3D solid. These are called nets. So basically, if you were to fold this all back together, you would get a solid shape. Okay, so think about if I were to take this point and kind of bring it to the middle, each one, right, what shape would this be? And this would be let's see, there's on the bottom, the base, 1, 2, 3, 4, 5, 6, 7, 8 sides. So this would be an octahedral, octagon, let's see, how would I say that? An octagonal, I think. An octagonal, and it goes to one point, so that's called a pyramid. I think I'm saying that right. Octagonal pyramid. If there would be another one of these as a second base, that would be an octagonal prism, but since it comes to one point, it is a pyramid. This one does have two bases, the second one, where this and this are the bases. So if you fold that back together, this would be a triangular. A triangular, and there's two bases, so a prism, P-R-I-S-M. Triangular prism. Right, and that should do it. So I think there's an assignment online for you.